It shows we've defined force as a push or a pull. We know an object will move if there is an unbalanced force pushing on one side of the object, which will accelerate in that direction. We know that because of Newton's second law, that an object will accelerate in the direction and with the same intensity as which direction that the force is being applied. These are Newton's three laws. The first law, an object in motion will remain in motion unless acted upon by an unbalanced force. Newton's second law, the acceleration of an object is the same as the force on the object. And his third law, to every action force there is an equal and opposite reaction force. We can calculate Newton's second law by using the equation acceleration is equal to the net force divided by mass, or A equals F over m. We can rearrange the equation so we can use force as our unknown, and we know an object's mass and its acceleration, we can determine how much force is being applied. Let's look at some sample problems where we use Newton's second law of motion. You push a wagon that has a mass of 8 kilograms. If the force on the wagon is 4 newtons, or 4 kilograms, times meters per second squared, what is the wagon's acceleration? We can use Newton's second law, where acceleration is equal to the force being applied divided by the mass. We plug in our numbers. The force is 4 kilograms times meters per second squared over 8 kilograms, which is force over mass. We plug that into our calculator, or simply think about 4 divided by 8, and we'll find out it's 0.4. Remember that units are important. When we set up this way, we know that we can cross out kilograms, and we actually end up with our units that we're looking for, which is acceleration, meters per second squared.